Hi, and welcome to the second video on finding areas using integration or definite integration. So I've got a function here that I want to start with. I'm going to talk about some of the effects of crossing the x-axis. So here's a pretty simple one. Y equals x squared minus 1, and if I sketch that function, I get this. X squared minus 1 starts at minus 1, and it's just like normal x squared, but it's been shifted down this time instead of up. So we've got our x-axis and we've got our y-axis. Now, let's say I wanted to find the area below this function between 0 and 2. So what's going to happen is I'm going to find this area and this area. That's what the algorithm will calculate. So let's do that algorithm quickly just to remind ourselves. So we're finding the integral between 2 and 0 of x squared minus 1 dx. Okay, now it looks to me like this area here is probably going to be slightly bigger than this area, but I'll get two areas added together. Let's see what happens. And when I do that, I get a third x cubed minus x. Remember, we don't need that plus c between 2 and 0. Now, polynomials are really nice when you have 0 as one of your boundaries. And you substitute that in, it just becomes 0, so that's really nice, particularly without the plus c. But I'm going to go through the whole process. I just have to make sure I get it right. Minus 2 minus, so I'm going to put brackets around that, brackets around this, a third 0 cubed minus 0. If you're massively confident you can get it right every time, okay, but it's still not great working. It's really good to show that first initial substitution step. But what I do get is 8 thirds minus 2. And then over here I get minus 0. And that's equal to 2 thirds. So this area is 2 thirds. Now just a couple of ordinates on here. This is 0, 1, and this is 2, so this is 2, 3. And so if I just drew some rectangles on here quickly, that's 0, 1, this is 1, so it should be negative 1. 1, negative 1. And so this is probably about half of that. That's at least a half, that area. This one here, this has got a width of 1, but that's 3. So this box, has an area of 3. And so this is maybe a little bit less than half of that, but it should be close to 1.5. So this area should be close to 2. But I've got 2 thirds, not negative, but 2 thirds. That's problematic. And the reason is because this is coming out negative, because it's below the x-axis. And we'll see a little bit more why later on, but for now, you have to recognise that if your function crosses the x-axis, that's a problem for you, and you need to split it up into 2 calculations. So I've got from 0 to 1, and then 1 to 2. So what I'm going to do is just quickly rub this out, and we'll do this calculation again. Wham! So, 0 to 1, 1 to 2 are our boundaries. So what I'm going to do is I'm going to say that the area, or area 1, which is the one below here, is equal to the integral between 1 and 0 of the function x squared minus 1 dx. And so hopefully you can see that that's equal to 1 third x cubed minus x between 1 and 0, which is equal to 1 third times 1 cubed minus 1 minus 0. And that's actually equal to negative 2 thirds. And we expected that because this is below the x-axis, so it's negative. So we knew that was coming, and now we've got what we thought. Now, there's a lot of ways that people deal with this. And so you'll see, if you read widely, you'll see lots of different things. People will tell you different ways to deal with it. You could swap the 1 and the 0 around. If you know it's negative, you could swap those two around. It will actually make it positive, which is nice. The other thing you could do is just throw a negative at the front, which is actually my preferred process. You know this is going to be a negative area, throw a negative at the front. The other way you could do it though is just recognise that you just have to take the absolute value. You just need to recognise that the actual area is 2 thirds. Really, how you approach dealing with the negative doesn't really matter. As long as you've got some clarity in your working and the person marking your working can understand what you're doing, then there's no big problem there. Area 2, on the other hand, comes out a little bit nicer, although a little bit rougher as well, because we don't get this nice 0. Anyway, I've got x squared minus 1 dx between 2 and 1. So now I've got x cubed over 3 minus x between 2 and 1, and that gives me 2 cubed over 3 minus 2 minus 1 cubed over 3 minus 1. That's 8 thirds minus 2 plus 1 third plus 1. 8 thirds plus 1 third. Oh, sorry, that shouldn't be plus, that should be minus third. 8 thirds minus 1 third is 7 thirds plus minus 1, and that comes out as 4 thirds. So I've got an area 1 of, and because it's already positive, I've got that. Therefore, the area total is equal to area 1 plus area 2, and I might write it like this. And that is equal to 2 thirds plus 4 thirds, which is 6 thirds, which is 2. And we're dealing with a unit square. Now, what's really important to note here is that earlier we did this problem, and we did it without finding that 1. So we just calculated the area total was equal to the integral between 2 and 0 of x squared minus 1 dx, and that came out as 2 thirds. It's all good and well. Here's something which I'll point out again to you. This I've written as 2, and I've put a unit squared because this is the area. We've got the positive area, the negative area, we've made the negative area positive, added them together, that's our total area. Over here though, we've got 2 thirds. 2 thirds is not an area representation, but it is the definite integral. So just keep that in mind. 2 thirds, if you're just asked to calculate the definite integral, there's no mention of area, the context doesn't imply area, this is technically that calculation. If you're asked to do this calculation, you don't need to find points of intersection with the x-axis. So just be aware of what the question's asking. Anyway, I'm going to do one more example with you now, and that will be on the next video. Thanks.